question shows a theoretically possible but practically impossible mechanism for a hydrogen hydride shift for a carbocation rearrangement. Why is this mechanism incorrect, and how can we prove that on an energy diagram? Well, first, let's draw the actual correct mechanism for hydride shift. If we wanted to do a hydride shift from a secondary carbocation to a tertiary carbocation, we would take this hydrogen and we would shift the hydrogen directly in one concerted step directly to form the new tertiary carbocation. This concerted step, we'll start by drawing the reaction coordinate diagram for this one. For the concerted step, we would start with our starting material. And it would go directly to a more stable product. And it would have some kind of activation energy associated with it to do the hydride shift. Our incorrect mechanism shows hydride leaving as a leaving group. So that's problem number one. Hydride is a terrible leaving group. It is a very strong base, a very unstable molecule. It can't leave on its own as a base under standard conditions. And then it would go through a dication intermediate, two carbocations right next to each other in the molecule. This is highly destabilizing. So starting from the same starting material, if we were to draw the reaction coordinate diagram for this, it would look, something like this. To get to an intermediate, which would then eventually get back to the same product. It would have such a high activation energy that it wouldn't even be on the scale anymore. It would be so incredibly high in energy to even attempt this type of mechanism that the concerted mechanism that we all know would be, in fact, the more favored pathway for this particular hydride shift.